This is a video on assembling the electronics for your lightsaber. Fairly basic electronics, provided you know how to use a soldering iron. It's fairly simple. If you don't know how to use a soldering iron, well, there are plenty of tutorials out there. If I get a few requests for it, I will do a basics of soldering video, but I don't think that should be necessary. Okay, so I'm now going to wire up the LED. Positive these two contacts, negative are these two. Electrical standards, red is positive, black is negative. So first off, I'm going to apply some solder to the contacts. You don't really need to put solder on all four, but I am. Okay, so positive is this one, so I'll just apply some heat to the solder on there, and that melts the wire straight on. Then this is one of the negative ones, so again put a bit of heat and it just melts straight in. So I'm now going to test it. This is going to be bright, apologies. Yep, definitely working. As you can see, that's an amber coloured LED. I've got a few different colour LEDs available, so I'll get them all soldered up, just so I've got a changeable blade colour. Okay, now we're soldering up the battery pack. This here is a 4x AAA battery pack. It's got a PP3 connector on one end. This here is a PP3 connector, the sort of thing you'd find on the 9V batteries. Now, as I messed up the last take of this, I've already got the wires stripped back and twisted up. So what I need to do is add some heat shrink tubing. This is to A, hold the two wires together, and B, cover up the seams. So I'm just going to wrap up the wires neatly. Now what I need to do is twist them together, black to black, red to red. Now, I'm not sure if soldering iron is up to temperature yet. Yeah, it is. Great. So, all I'm doing is holding the soldering iron on the wires whilst I apply some solder. The solder is a mixture of metals which melt at low temperature and widely used on printed circuit boards. It used to be tin and lead. They were banned from using lead because of lead pollution. I'm not quite sure what the other elements used these days are. But yep, that's the two bundles of wires stuck together. Now what I need to do is slide the heat shrink tubing over them. So that's the heat shrink in place. Now, as the name suggests, it shrinks with heat, so I'm using the back of a soldering iron to make them shrink. I'd advise against using the tip for this, because you don't really want to have to clean this stuff off the tip. It does leave a residue behind. And yeah, you need the tip clean when you're soldering. Okay, so now I can slide the two smaller pieces midway down the wire to help me keep this all together. Now I can just slip the PP3 connector into position. And here's the battery pack assembled, except for batteries put in it. So this is a simple little latching click on click off switch. Comes with a retaining pin and is roughly the right size for the hilt. So what I've done is set off a retaining pin. You can see there's two contacts there. What I need is to wire in a male and female quick connect. Now again, you can just wire the whole thing permanently. One wire going from the battery pack to the LED, the other wire going from the battery pack to the switch to LED, if that's what you want to do, but I much prefer to be able to just swap out the damaged component quickly and easily, which is why I use the quick disconnects. So, as before, you want a bit more insulation. Oh, sorry, you want to strip off the insulation to give you a bit more wire to work with. Now, it doesn't really matter which wire you use for positive and negative. Oh, sorry, for whether you use positive or negative with the switch. I'm plugging in a hot glue gun because I'm going to want that in a few minutes. So, what I'm going to do is slide a few heat shrinks onto each. What I want is one to hold each pair of wires together. And an additional one for the seam. So in this case I'm going to make the neutral or black wire the seam. So I've slid an extra heat shrink onto one of the blacks. Now, what you can do is slide the wire through the hole in the middle of the switcher's plate here, but I prefer to wrap them around the outside. That way, if they come off, it's much easier to solder them back on. So, wrapping it around like so. Now, apply a bit of solder. You don't want to get the switch too hot because most of them have got plastic housings which will melt if you let them get too hot. So yeah, by going through the wrap around the outside, if the wire snaps off or something stupid like that, you can just resolder over the top. If you go through the middle, it might take the whole connector thing off if you snap it. So that's the other one soldered on. Now I just need to wrap the two neutral together. As you can see, the neutrals, oh wow, that's almost spot on. Yep, the black wires are almost perfectly aligned, so I just wrap them together. Then solder them. Now I can just fold this back and slide the heat shrink over. Now I can just slide the others into position. I'm just after keeping the wires paired up so they don't get too tangled. And then again I can just shrink it down. Okay, so there you have it. Switch wired up. If you know basic electronics, it's fairly simple. I had my, at the time, 8 and 10-year-old niece and nephew make them a few years back. Yeah, they had a bit of supervision, but they actually got further than my sister, their mum, did. Now, as I said, I powered up the heat gun because after using the hot shrink glue gun, because I'm after using that to remove stress from the contacts and also to hold everything in place. So generous blob of hot shrink, hot melt, and then should have dampened my fingers first. Okay, so that both insulates it and helps remove a bit of stress, otherwise they're less likely to break off. Admittedly, if the wires do break off, I've given myself a bit of extra work, but I've got plenty of switches. Thought it'd be easier just to swap the switch out. Now, before we put the LED module in, we need a heatsink and a reflector for it. This here is an aluminium heatsink, fairly cheap. You can get them off eBay or wherever. The Custom Saber Shop also sells their own line of heatsinks. They're going to be better than this, but they're also quite a bit more expensive. You're also going to need a reflector. Lens. What this does is focuses the light from the blade into a fairly small arc. You're going from a 180 degree emission angle to about a 5 degree emission angle. It helps to throw the light down the blade. So yeah, both of those are helpful. Not essential. I mean, I don't know for sure, but the LED will definitely burn out if you don't have a heatsink, but I don't feel like trying it. And the reflector definitely makes the end result look a lot brighter. So what I'm doing is routing the wires down the side of the heatsink and attaching that to a reflector. I'm then getting a length of aluminium tape. Doesn't have to be aluminium tape, I just like using it. Duct tape would probably also work, but when that gets off, the adhesive becomes less effective. I've just always used aluminium tape and never had a problem with it, so I've stuck with it. Okay, so heatsink, LED and reflector, wrap the aluminium tape around them. That holds everything together. Then I'm just tightening it off of the bottom to give you a nice shaped bundle. If you enjoy the video, please watch some of my others. I've done a whole series on building your lightsaber. If you have any questions or suggestions, please put them in the comments. And thanks for watching.